Assalamu alaikum warahmatullahi wabarakatuh. Welcome back in another video, in another presentation of another paper. And this paper is about fundamental physics and computation, the computer-theoretic framework. And there's the introduction of this paper. And the name of this paper is Fundamental Physics and Computations, the computer-theoretic framework. And it was published in 2022. And what is the goal of this presentation is summarize the computer theory framework, CTF, and its potential implications for physics, positioning computation as fundamental to physical law, and historical context of computation in physics. From Turing machines to quantum computing, early integration, pioneers like Alan Turing and Konrad Zuse proposed early modules that connected computation and physical reality. Conceptual evolution figures such as Richard Feynman and David Deutsch introduced quantum computing, expanding the concept of computation in physical models. Key terms, foundational ideas like the Turing machine and quantum computing emerged, influencing theoretical approaches to physics. And this is a photo by David Conry on Unsplash. And there are 7 objections to the computational universe hypothesis. Challenges to viewing the universe as a computational system. The first is radioactive randomness. Critics argue that phenomena like radioactive decay resist predictable computational modeling. Continuum in nature. Continuous physical process challenge the discrete nature of computational framework. Evolution was computation. Some physical process emphasize evolution rather than the computer solving, raising limitations. In infinite dimensions, quantum mechanics relies on infinite dimensional spaces, which are difficult to model computationally. Lagrangian schema, the universe may follow principles like least action, distinct for computation. Role of observers, quantum observation affects system in way difficult to replicate computationally. Uncertainty principle, the Heisenberg uncertainty principle implies inherent predictability clashing with computation-based models. Computer theory framework, CTF. Introducing principle of computability, introduction of CTF proposes the principles of computability, positioning computation as a fundamental aspect of the universe. And principle of computability suggests computational limits and power as concerns, unlocks to physical concern like speed and light. Broad computational power includes probabilistic and quantum computation, not restricted digital or deterministic system. And applications and implications in physics, quantum computing, irreducibility, and reinterpretation of laws. Quantum computing, CTF may offer new sights into quantum supremacy, complexity, and computability in quantum systems. Computational irreducibility, certain systems are too complex to simplify, reflecting phenomena like black holes. Reinterpretation of laws, CTF provides fresh perspectives on space-time, field theories, and even multiverse concepts. And the conclusion of this paper summarize the computer theory framework that summarizes CTF. Summary of CTF proposal suggests computation as a core principle fundamental to understand the universe laws. Future direction, open questions about CTF applications, potential empirical tests, and impact on unresolved physics issues. Paradigm shift encourages rethinking the universe through a computational lens, potentially unifying computation with physical theory. And thank you for the presentation.